Okay, we're going to take a look at question 5 out of 9.2. This takes data from dataset 26, COLA weights and volumes, and we're looking at the weights of the contents of cans of Diet Coke and that of regular Coke. They do give us the summary statistics here, and they want us to use a 0.05 significance level to test the claim that the contents of cans of Diet Cokes have weight with a mean less than that of the mean of regular Coke. And then they want us to explain why cans of Diet Coke would weigh less than cans of regular Coke, even though we haven't concluded that yet. I wonder if they tip their hand on what we may discover here. Again, we want to go ahead and identify what the claim is. So our claim is that the mean of Diet Coke is less than that of the mean of regular Coke. And they're measuring this in pounds, and when they're measuring this in pounds, if we're looking at the sample means, those numbers probably look really close to each other just from first glance, but again, it's the standard deviation that puts whether or not things are close into perspective here. So that's why we have to kind of ignore what we're seeing in the sample means and move on, run through the formal process. So let's do the opposite case. So the opposite of the mean of Diet Coke being less than the mean of regular Coke is that the mean of Diet Coke is greater than or equal to the mean of regular Coke. And now we can set up our hypothesis statement. Again, HO, HA, those are just labels. They're not equal to anything or greater than anything. They're just labels. So whatever we listed first in our claim is what we should list first here. Whatever we listed second is what we should list second here. What goes between them and the null? Equals, because it's always equals in the null hypothesis. The alternate hypothesis gets the strict inequality, that is the less than that we saw in the claim. And speaking of what we saw in the claim, when we put the R and the S here, it is the S that represents, or it's the alternate hypothesis that represents the claim. So that's why we're going to make a note on our S here. So when we get down to stating the conclusion with respect to the claim, that S is for support. We will talk about whether or not we can support the claim. Moving on, this is a left tail test because we're looking at the inequality in the alternate, and that's pointing to the left. Our significance level is 0.05, and significance level is alpha. And it wants us to identify all the given statistics. What I'm just going to do here is make a note that Diet Coke is sample 1 and regular Coke is sample 2. They've already listed everything out with our proper symbol there, although we could have made those X bars if we wanted to. So there's no point in really writing them again there. We can also write our rule of rejection, and that is reject null hypothesis if the p-value is less than or equal to whatever alpha is, our significance level, and that's 0.05. So again, we're using the p-value versus significance level to write our rule of rejection. So our test statistic is going to be t, and if you don't know that it's going to be t ahead of time, StatDisk will be nice enough to tell you that. I happen to know it's going to be a T ahead of time. So now we're ready to go ahead and bring everything over into StatDisk. So let's go with a new share, head on over to StatDisk here, and this is going to be analysis, hypothesis testing, and when we're working with means, there's two possibilities. Now, we're looking at a collection of cans of regular Coke, a collection of cans of Diet Coke. Is there any inherent pairing of why the first can from one group would be equivalent to the first can of the other group? No, there's not. This is an independent sample. Also, if they give us summary statistics, we know that we're going to be working with independent samples as well. So to start out, pick the appropriate alternative. It was a less than, so pick the less than. The significance level, that's 0.05, so we can leave that alone. Now for the Diet Coke, that was 36 for sample size, 0.78479 was the sample mean, and 0.00439 for the sample standard deviation. We had 36 cans of regular Coke with a sample mean of 0.81682 and a sample standard deviation of 0.00751. In terms of method of analysis, we're going to leave the unequal variances no pool checked unless we are explicitly told otherwise. So we're going to leave that. We can hit evaluate. Let me move this over. We can also go ahead and hit plot. And what we see in the plot is this is a lower tail test, and our lower tail gets cut off by the critical value here at negative 1.672. And we're going to reject if our test statistic ends up in that left tail, and it does. And not only does it, our test statistic was negative 22.092. So this is saying that the sample result that we got is more than 22 standard deviations away from what we would have expected if these two population means were equal. That is a long, long way away. So let's just go ahead, copy this information back into where we're writing this up. So our t-value here was negative 22.092. Our p-value was, for all practical purposes, 0. It's not identically 0, but it's going to go out quite a few decimal places before it gets to something that's a non-zero number. So 0 is less than 0.05. We said we would reject the null hypothesis if we got a p-value less than 0.05. We did, so we are rejecting the null hypothesis. And when we reject the null hypothesis, that is when we have sufficient evidence to, oh, why are you gonna, okay, let's just do this then. So we have sufficient evidence to, now we go to the S there, support the claim that, let's take this back a little bit. Oh, why is it giving me such problems? Let's try this, because that tends to work. The contents of cans of Diet Coke have weights with a mean that is less than the mean of regular Coke. So again, this conclusion with respect to the claim, it's built out of three pieces. What happens when, with the null hypothesis, whether we reject, fail to reject, that addresses the first part of whether or not we have sufficient evidence. When we reject, we have sufficient evidence. When we fail to reject, we don't have the evidence. We would have insufficient evidence. Then whether or not you're talking about rejecting or supporting the claim, that comes from what part of the hypothesis statement represents the claim. That's why we do the R and the yes up there to let us know if we're going to end up writing reject or support. And then the last piece is a literal copy paste from what the original claim was. So now that we've written that out, let's read it all the way through. We have sufficient evidence to support the claim that the contents of cans of Diet Coke have weights with a mean that is less than the mean of regular Coke. So we rejected the null hypothesis. We rejected the idea that the mean weights of Diet Coke and regular Coke were the same. So we're going with the alternate, and that's that the mean of Diet Coke is less than the mean of the regular Coke. So yep, we're concluding that cans of Diet Coke weigh less on average than cans of regular Coke. So yeah, what they are asking us to address in part G is actually the case. So now to go ahead and explain why cans of Diet Coke would weigh less than cans of regular Coke. Now this has nothing at all to do with statistics. This has everything to do with our knowledge of cans of Coke and Diet Coke. Well, they're both 12-ounce cans, so they should be filled to about the same level, but that would be an interesting thing to check to see, are they actually putting the same amount of liquid in each of these cans on average? Are the cans constructed the same? So, if they're using the same material, same thickness, all that, so if it's not due to the fill amount, if it's not due to the weight of the cans, if it's simply the contents, and if we had 12 ounces on the nose of Diet Coke and 12 ounces on the nose of regular Coke, and we're concluding that Diet Coke is weighing less, then it must be something about what the ingredients of these two sodas are. And that's when you would probably start looking at the ingredient labels and seeing, what is in one and not in the other. And, regular Coke does have sugar in it in one or various forms, whereas the Diet Coke does not. It has artificial sugar. So if we were to give an explanation, since it doesn't make sense that they would fill these to different volumes, it doesn't make sense that they would use different cans. If it comes down to strictly the ingredients, that would be our explanation. And just generically, without looking up the ingredients of Coke and Diet Coke, the difference in ingredients is probably going to be related to whether or not it contains sugar. So we've got all that done. Two quick notes about the output here. One is, keep in mind that StatDisk will tell you about the choices you made. So if your numbers aren't working out correctly, make sure that you put in the right choices there. And then the other thing is our confidence interval here. And our confidence interval here for the difference is made up of strictly negative numbers on both sides. The upper and lower limits of the confidence interval are both negative. Remember, the interval would have to contain 0 for these two quantities being equal to be plausible. So these are strictly showing up as negative, and negative is only going to happen if the first one was less than the second one. So this is telling us exactly the same thing that we concluded running through the hypothesis test process.